Okay. What we have right here is we're going to carry on and we're going to do another application, and this is going to involve trigonometric uh, uh, equations and using potentially inverse trig ratios to solve this. And so what we have is dealing with angle depressions. Okay, in my previous video I talked about angle of elevation. Well, now what we have is a global positioning system. All right, so we have a satellite right here, which orbits the Earth at about 12,500 miles above Earth's surface. You can see this figure right here. All right, wonderful world. All right, globe view. Find the angle depression. All right, here's the angle depression we're looking for from the satellite to the horizon. All right, from the satellite to the horizon. Okay, and so essentially horizon is on the tip of this right here of the globe. All right, that would be the horizon, and these are going to be tangent to each other, so it's going to be passing through. So that's the horizon. Assume that the radius of the Earth is 4,000 miles. Okay, so we're going to solve this. We're going to do this right here. All right, now to complete this, what we want to do is we want to determine some different values. Well, first off, when this comes from here down, all right, and this is going to, we're going to have these two values, okay, when the satellite, that this right here, and when it's orbiting, this is going to be a perpendicular line right there. Okay, so that's perpendicular. Okay, that's perpendicular. All right. And so when we have that perpendicular line right there, we know that we have some different angles. So if we have this right here, okay, we know that these two angles, all right, are going to be both 90 degrees, okay, add up to be 90 degrees. And so we can try to figure out, okay, what, and then we know that this is equal to 90 degrees, and together they equal 180. So one thing we're going to do is just figure out what angle we're solving for. Now, there is two different ways we could approach this. We have this angle right here, and we could try to figure out if this angle is equal to one of these, and it actually is. Because I'm going to call this angle A, we'll call this angle B. Well, we know that, and I'll call this angle of elevation, I'll call this angle D for depression, angle of depression. All right, and we know that the measure of angle B plus the measure of angle A, those have to equal 90 degrees, correct? They equal 90 degrees. We know that the measure of angle A plus the measure of angle D also has to equal 90 degrees, all right, because it's perpendicular going out. And so we can set these equal to each other. So the measure of angle B plus the measure of angle A has to equal the measure of angle A plus the measure of angle D. These two we can cancel out, subtract them. So we know the measure of angle, well, that should be measure, not B. All right, sorry, the measure of angle B has to equal the measure of angle D. Okay, that helps us out a little bit because if you want to find the angle depression, which is right here, we can actually find this angle right there. All right, we can find that angle right there. Well, that's cool. That's cool. That's really neat. All right, and we know this is 90 degrees because it's see the figure because it's coming straight out from here. All right, at this point and finding that right there. So there's following that. Okay, so creating a straight line, and then is the horizon. All right, creating a perpendicular from this point right there. Okay, creating a right triangle. Because we created this cool right triangle, and we know we're looking for the measure of angle D, which we know now equals the angle of a measure B, we're going to use, all right, a trig ratio. Okay, so the first step, all right, is we got to figure out is which trig ratio we're going to use. Well, we're using measure of angle B, and so what we have here is, what do we have? Well, we have a psi, which is 4,000. We have this other psi, because this is also going to be, all right, 4,000. Okay, and if you look at this, we have a hypotenuse, and when it appears we have adjacent sides. So we have an adjacent and a hypotenuse of a right triangle. Well, what uses adjacent and hypotenuse? That is cosine. Cosine of any angle of a right triangle is adjacent over hypotenuse. And that's what we got there. Cool. All right, so filling in our blanks, all right, what we have here is going to be, well, the cosine, all right, an angle, I'm going to just put B in there, so we're going to solve for B eventually, is going to equal adjacent, which is 4,000, over the hypotenuse, and if you add these two together, all right, we're going to have 16,500. All right, miles, 16,500 miles. And so from here, now we want to solve, all right, for measure of angle B, which we know equals the measure of angle D, which is the angle depression that we're looking for. So how do we solve for an angle? Well, we're going to use the arc inverse trig ratio. So we're going to take the arc cosine of both sides. And when we take the arc cosine of both sides, I'm going to have 4,000, all right, over 16,500. These will cancel out, and I'm left with B, which is our angle measure that we're looking for. Now we're going to put this into our calculator. So if you go here, now usually what does this look like in your calculator? You won't see any arc cosine. This is the same thing as the inverse cosine. So you'll see this in your calculator. All right, this is known as the inverse cosine. That is what you want to use, my friends. All right, so you're going to take that and plug that in your calculator. So if you have a TI, you probably have to press second or something like that. But you go second, all right, cosine, then you got that inverse symbol, and you go 4,000 divided by 16,500. And what we get here is, it says, at least for my calculator, and I have it in degrees, so this is going to be in degrees, I have 75.97, all right, 0, all right, degrees. That is the angle of depression. There we go. Boom, angle depression. All right, so how did we get here? Well, first off, they gave us a nice little diagram, or if we didn't have a diagram, we have to write this out, but they did, so that was nice. But when we have this, the first thing is identify, okay, what's your angle depression? All right, angle depression. All right, this is coming out to the horizontal horizon, which is right here. We identified with our right triangle what that angle could be. All right, that's one thing you want to do. We knew this was perpendicular, and using a little bit of geometry and trigonometry as well, we identified that these two angles, angle A and D, would be equal to 90, and so would B and A would be equal to 90. Solve that out and realize that B and D are going to be equal. Once we realize that, we then figured out, okay, knowing that we have to solve for this angle, looking at a right triangle, which sides were we given here? Well, from this angle, this was adjacent and the hypotenuse, so we were using cosine. The cosine of angle B would equal adjacent or hypotenuse, and so then we plugged in our values. After we plug in our values, get a good old trig inverse, all right? Use the trig inverse here to help us solve it, okay? Put in our calculator. Our cosine is a trig inverse, but we also know that inverse cosine, which is a little -1 that you see on your calculator, which you need to use. You can use that, and when we do that, we get an angle degree measure of 75.970. Okay, so I hope this helps you out on solving various different other application problems with inverse sine and cosine, or even tangent. All right, good luck and God bless the rest of your problems.